Okay, so you're going to do a couple more questions now, and you might like to pause this and have a go yourself, and then see how I go through with this one here. So we've been told the center of this particular circle, and we've been told that it's passing through this point P and this point Q. The first thing it wants us to do is to show that PQ is a diameter of the circle. Now, I like to do a bit of a sketch for this to visualize what's going on here. And like I've said before, it doesn't need to be an accurate kind of sketch. So for this sketch, we have been told that A is the center, which is 3 minus 1. It doesn't matter where you put the points at all. I'm not going to try and put them accurately. I'm going to put P up here, and I'm going to put Q on the other side because they've said that PQ is a diameter. Now, think to yourself, if PQ is a diameter, which I'm just going to draw on here, then you should know something about their properties to show that it's a diameter if it is a diameter. Well, if it is a diameter, then the center will also be the midpoint. So for that first question, I'm going to find out the midpoint of PQ. And the midpoint of PQ, I'm going to call it capital M, is just going to be the average of the x coordinates. So that's 15 minus 9 over 2. And the average of the y coordinates, that's minus 10 plus 8 over 2. So the midpoint is 6 over 2, which is 3. And minus 10 plus 8, that's minus 2 over 2. And that's minus 1, which is great. Because the midpoint of PQ is the center of the circle, because they match this one that we've got here, is the center of the circle, PQ is a diameter. Now, there are other ways you could do this, and I'll show you the mark scheme afterwards so you can see there were different ways of going about this, okay? So get rid of that underline there. Part B of the question wants us to find an equation for the circle. So if we're looking for an equation of the circle, we need two things. We need the center and we need the radius. Well, we already know the center is 3 minus 1, so we just need to figure out the radius. Now, the radius is either going to be AP or AQ, but we'll just work out either one of those. So for part B of the question, AP is the radius, which is the square root of, so the difference between the x coordinates, it goes between 3 and minus 9, so that's 12. And the difference between the y coordinates is between minus 1 and 8, which is 9 squared. So we've got 12 squared plus 9 squared, 12 squared plus 9 squared. So it's the square root of 225, and the square root of 225 is 15. Now, I'm going to have to square it in a second, so might as well leave that there. So the equation of the circle is x minus 3 squared plus y plus 1 squared equals the radius squared, which is 225. Great. So we've done both parts of those questions, and now is where things get interesting. The point R also lies on the circle. Given that the length of the chord PR is 20 units, okay, before we even read what the question is, I think I'm actually just going to draw this diagram again, and I'm going to now add in R on that circle. So again, it's just a sketch. It doesn't need to be accurate because we don't know many things about it just yet. But I do know that we have the center of the circle is A, which is 3 minus 1. I know that I've got P over here. It doesn't matter if it's over here or on the other side. It's just where I've put it, because this is just a visual tool to help us think about what's going on. And we've got R somewhere else. But first of all, I'm going to add in that that's a diameter. I'm going to put R up here. Okay, so we've got this angles inside a semicircle kind of thing going on. And I might move R. No, I'm going to leave R there just to show you it doesn't matter where you put it. Even though clearly PR, they've told us, is 20. And we know that the radiuses are 15. So I am going to zoom in on this diagram and I'm going to add in some of the lengths I know. I know that AQ is 15, AP is 15, and RP is 20. If I wanted to, I could also add in a length between A and R like this, and I know that that length there is 15. Okay, let's actually find out what the question wants us to do. It says, find the length of the shortest distance from A to the chord PR, and it wants you to give your answer as a surd in its simplest form. So I'm going to find the shortest distance from A to PR. This is where you're going to use a bit of common sense, okay? Here is A, here is the chord PR, and I want to get from here to that line as quick as possible. Now I could travel along here, I could travel along here, but neither of those are going to be the quickest way possible of getting there. The quickest possible way of getting there is along this line that will meet the chord at right angles. So what I'm actually trying to do is I'm going to try and find out this distance here that will meet at right angles, because that's the shortest distance. Now, if it's meeting it at right angles, then we should know something about this distance running along here. It won't be 20, that distance is actually going to be 10, okay? That diagram's getting a little bit busy, so I'm going to redraw this triangle that I have here. I'm going to just redraw it separately. So here it is being redrawn separately. That's a right angle. We said that's 10, that's P, that's A, and that's 15, and this is the shortest distance that we're looking for here. So what connects those sides of a triangle together? It is Pythagoras. So the shortest distance D is going to be the square root of, remember you're going to be doing a subtract here because you're not finding the hypotenuse, 15 squared minus 10 squared. So let's just go straight in with that calculator, 15 squared minus 10 squared, and we get 5 root 5. So the shortest distance is 5 root 5 units, okay? Now equally, I could have put r all the way over here, but it's not really going to change anything about the question. You're still going to end up with a right-angled triangle that looks like this. Okay, let's now see what they want us to do for part D of the question. I think these are really hard because they require a lot of like logical thinking. So it's always about thinking about all the properties that we know of circles. So it wants us to find the size of angle ARQ to the nearest 0.1 of a degree. So it is ARQ. Let's have a look at this. So we have ARQ that we have here. Now this is a pretty difficult angle to try and imagine how you're going to do it. And let's label what we're looking for. Now I am looking for this angle that I have here. Okay. Now I know something about this because I know that this line is 15 and this line is 15. So I'm hoping you can tell me that because this and this are equal to each other, the triangle ARQ, this is for part D, ARQ triangle is isosceles. I'm hoping that you can spot that, meaning that this angle is the same as this angle. These are the same because it's an isosceles triangle. So instead of finding out this one, I could find out this one. Now, it's getting super busy, this diagram, but I'm hoping that you could spot some other angles we knew about right back at the beginning, and that is that this is a right angle here, that PRQ is a right angle. The triangle PRQ is a right angled triangle. So PRQ triangle is right angled. And the reason that PRQ is right angled is because PQ is a diameter and that triangle is inscribed in the circle. That's one of those GCSE theorems as well. So I'm actually going to draw out PRQ. There is P, there is R, and there is Q. That has a right angle. And remember, this angle that we're looking for is the same as this angle that we've got here. So in fact, I'm just going to find out what this angle here is. I'm going to call it theta. I know that the length between Q and P is 30 because it's a 15 and a 15. And the length between R and P is 20. Now, this is suddenly going to look really simple, which is why it's only 2 marks. The thinking is really hard, but the maths is actually really simple. So this is my angle. I've got the opposite and I've got the hypotenuse. So the thing that connects them together is theta. So the opposite is 20, the hypotenuse is 30. So theta is going to be the inverse sine of 20 over 30. The inverse sine of 20 over 30, which is 41.8 degrees. So theta is 41.8 degrees, okay? Let's have a look at the mark scheme. There are many ways you could answer these. It's kind of interesting to see what they've done. So for part A of the question, one of the ways was doing the midpoint. That was the way that we did it. Another way that this was done was having a look at the gradients and then the equations of the lines to try and show that it was a diameter, but not my favorite kind of method. And then another way that they did this was to show, oh goodness, what are they doing here? They're finding the length of PQ, the length of AP, and the length of AQ, and that shows there's also a diameter, but I way prefer this part A. Part B we did fine, we got that equation. Part C we did fine, and then this was actually what we worked out here. We got that sine of theta equals 20 over 30, but not very easy to spot. Okay, let's move on to the last exam question here, because they're kind of demanding. So I've got this nice diagram that's been drawn. Let's read through what we've got. The circle C has center A with coordinates 7, 5. Well, why haven't they put that on the diagram? It's so annoying. So that is 7, 5. The line L with equation y equals 2x plus 1 is the tangent to C at the point P as shown in figure 3. So this line here is y equals 2x plus 1, and there is that point P. Show that an equation of the line PA is 2y plus x equals 17. So I'm actually just going to go straight on here, and I'm going to draw the line PA, the line that is going through P and the line that is going through A. Well, I'm hoping very quickly we can spot that they are perpendicular to each other, and that this line here goes through, it's kind of obvious to say, but it passes through P and it passes through A. So we can work out what its gradient is because they are perpendicular. Okay, let's go. Let's start that off. So the gradient of PA is going to be perpendicular to this one's gradient. Now the gradient of this one is 2, so the gradient of PA is going to be minus a half. And the equation of this line, well, I don't know what P is as a coordinate, but I do know it passes through A, which is 7, 5. And so it passes through A, which is 7, 5. So we're going to go straight in with our formula, which is y minus y1 from here equals m brackets x minus x1, which is here. And we're just going to hope that it rearranges to this. So I'm going to multiply both sides by 2. So it's 2y minus 10 equals minus x minus 7. So 2y minus 10 equals minus x plus 7. I'm going to add the x to this side, and I'm going to add the 10 to the other side. And we get the correct equation that 2y plus x is equal to 17. Now part B of the question just wants us to find an equation for the circle. I'm going to write this down one more time. We need to know two things, the center and the radius. Well, we already know that the center is 7, 5, so we just need to work out what the radius is. Now, how am I going to find out what the radius is? Because I don't really know anything about this. I really want to know the distance between A and P. That's the radius. But I don't know what P is. So you need to think to yourself, how can I find out what P is? How can I find P? Now remember, you've got loads of other skills here. P, let me just quickly say, this equation we know is 2y plus x equals 17. And P is where those lines cross. Ah, good. If it's where the lines cross, we're going to solve those two lines simultaneously. We're going to solve y equals 2x plus 1 and 2y plus x equals 17 simultaneously. Now, if you wanted to, you could just put that in your calculator, but I'm going to just substitute this one into here. So I get 2 lots of y plus x is equal to 17. So that's 4x plus 2 plus x equals 17. So 5x is 15 and x is equal to 3, which means that y, using this one that I've got here, is 2 times 3 plus 1, which is 7. So this means that P is 3, 7. Now why was I finding P? Oh yeah, because I wanted to find out what the radius was. So if I want to find out what the radius was, let's say that the radius is the same as AP, which is, let's just write down what A is. A is 7, 5, and P is 3, 7. So the difference between the x's is 4, and the difference between the y's is 2. So the radius is 16 plus 4 is 20, so that's root 20. So my equation of the circle is going to be x minus, right, what was that, 7 and 5? X minus 7 squared plus y minus 5 squared equals the radius squared, which is 20. Not an easy question. Okay, only 4 marks. Quite a lot of work. Okay, there's two ways of solving this last one, and I'm going to do it in two different ways. So we have the line with the equation y equals 2x plus k, and k is not equal to 1, because we'd then be talking about this one, is also a tangent to C. Find the value of the constant k. So I'm going to look at this diagram for a second. I'm hoping that you will be able to see the other place where there could be a tangent that is in the form, whoops, y equals 2x plus k. Well, it's got the same gradient, but a different intercept. So it looks like the place that it would be somewhere along here. Oh dear, that straight line didn't go so well. Somewhere along there, but touching the circle. Okay, it isn't touching the circle. Now, if I call this point where they're touching here, if I call that Q, and if I can find that coordinate, then that should help me to figure out what K is. So I'm going to do this one kind of using logical reasoning, and I'm actually going to redraw a diagram down here because that diagram is getting really, really busy. So I think this is part C. Okay, we've got our axes, we've got our circle, we've got one of them here, the one that we're trying to find here. P was 3, 7. A was 7, 5. And if I find out this coordinate, if I call it Q, I could actually figure out what this is by using some common sense. Now have a look at this. To go from P to A, we're moving in this direction. And then to go from A to Q, we'd be moving in exactly the same direction. So the x coordinate is going 3, and then it's moved along to 7. It's increased by 4. So the x coordinate is going to go all the way up to 11 here, because 7 plus 4 is 11. Now the y coordinate is going 7, and then it's gone down to 5. So because it's doing the same journey, it's going to go down 2 more, and it will be 11, 3. Okay, that's why this isn't many marks, this question. And I know this one was y equals 2x plus 1, and this one is y equals 2x plus k. So this equation has got this coordinate on it. That means I can just substitute them in straight away. I can say that y is 3 and x is 11, and I can put them in here. So 3 equals 2 times 11 plus k. So 3 equals 22 plus k. So k is equal to minus 19. Okay, that is one of the ways of doing the question. I think probably the harder way of doing the question. The other way is by doing simultaneous equations, because we know if there is a tangent that when you come up with the discriminant, your b squared minus 4ac will be equal to 0. So I'm going to solve y equals 2x plus k, and my circle equation, which is x minus 7 squared plus y minus 5 squared equals 20 simultaneously. And because there will be a tangent, that means that b squared minus 4ac is going to be equal to 0. This is a lot more work, and considering it is only 3 marks, it's a lot more work to do. But let's go for it. So we have x minus 7 squared plus y is going to be 2x plus k. So we get 2x plus k minus 5 all squared equals 20. So it's a lot of work. So we have x squared minus 14x plus 49 plus, I'm going to treat this k minus 5 as one single thing, okay? So when I expand these brackets, I would get 4x squared, that's squaring this bit, plus 2 multiplied by, because you get 2 of these, 2x and k minus 5, plus the k minus 5 bits squared is all equal to 20. This is so much more work. So this is why they really want you to spot this method. So you get x squared minus 14x plus 49 plus 4x squared plus 4x multiplied by k minus 5 plus k squared minus 10k plus 25 equals 20. I'm going to start collecting some things together here. So this and this gives me 5x squared. No, actually, I'm not going to collect anything together, not yet. I'm going to just finish expanding first. So that's x squared minus 14x plus 49 plus 4x squared plus 4kx minus 20x plus k squared minus 10k plus 25 equals 20. Way more work. Okay, so first of all, we've got the x squared terms, which are these ones. Then we've got the x terms, which are these ones. And then we've got the constants, which are these ones that we have here. I'm kind of regretting even showing you this because I don't want you to do it this way. So that's 5x squared plus x, and then we've got 4k minus 34. And then we've got the constants are going to be, this is crazy. I think I might abort this soon. K squared minus 10k, so that's 49 plus 25 minus 20 plus 54 is all equal to 0. So if we were going to keep going down this route just for these three measly marks, A equals 5, B equals 4k minus 34, and C equals k squared minus 10k plus 54. So B squared minus 4AC is equal to 0. So we get 4k minus 34 squared minus 4 times A times k squared minus 10k plus 54 equals 0. Oh my god, we're going to need another page. You can stop the video here if you've had enough. So that's 16k squared minus 2 times 4k times 34 plus 34 squared, which is 1156. And then we get minus 20k squared plus 200k. And then we've got minus 20 times 54 minus 1080 is equal to 0. So from these we get minus 4k squared. We've then got 2 times 4 times 34. That's 272 minus 272 minus 272 plus 200k. That's minus 72k. And then we've got 1156 minus 1080, which is 76. Have I got my graphics calculator here? Yes, okay. I'm now going to just put this on the graphics calculator. This is so much more work. I would not recommend doing this. We've got minus 4, minus 72, and 76. And this solves the equation that k is equal to 1 or k is equal to minus 19. Well, why do you think we've got this k equals 1? Well, if you look at k equals 1, it's referring to this one. So the other one that our answer should be is that k is equal to minus 19. So I kind of wanted to show you this other way of doing this method for part C of the question. I don't know why I called it part D. Is because this one is so simple, but it's really hard to spot. Whereas this one is the method that we've kind of learned how to do, but it's got a lot of demanding algebra just for 3 marks. So I guess my message, if you've got to the end of this video, is if you see something that looks like this and it's only 3 marks and you end up doing something like this, you should probably think to yourself, has something gone wrong? Let's just double check we've got everything right here. So that was that proof. We came up with the equation of the circle, and they've got this idea of what we were talking about of how you get that coordinate for Q is 11,3 and that K is minus 19. So yeah, maybe that's a bit of a message of if something's looking messy, see if you can go back and do it again in a more simple way. Okay, well done if you did get to the end of this video, and I hope you found that okay. Bye.